Section 9.6, Day 2, Polar Coordinates. We're going to learn how to convert points from rectangular to polar form and vice versa. So conversions of things that we already know in terms of rectangular and polar is we know the rectangular point is x comma y and the polar point is r comma theta. So to get a better idea, we're going to graph kind of in both planes. So this would represent the origin at 0, 0 when we're talking about the rectangular plane. This side would be x, this side would be y, and then the point, that unique point, is x comma y. Now, when we look at it in polar form, this point represents what we call the pole, and then this point, or this distance, is r, and then the angle from the polar axis to that ray is theta. So therefore the point in polar form is r comma theta. So recall, if I have sine of theta, I want to know what the ratio of sine of theta is. That is opposite over hypotenuse. So that would represent the y over r ratio. For cosine, it would be adjacent over hypotenuse, which is x over r. And tangent of theta is opposite over hypotenuse, which is y over x. So those are things that we've talked about in terms of our trig functions and their ratios. Now let's take a look at this a little closer. So if I say that cosine of theta is equal to x over r, that can be rewritten, if we multiply both sides by r, to x equals r times cosine of theta. Same thing can be done for sine of theta, where the ratio is y over r, multiply both sides by r, and we get y equals r sine of theta. Now why is that important? Well, x, which is in rectangular form, is equal to r times cosine of theta, which is in polar form. Same thing for y equals r sine of theta. So the left side is in rectangular form, the right side is in polar form. So we can use that for our conversions. We also know, using Pythagorean theorem, that x squared plus y squared is equal to r squared. And something else that's important at the top is that tangent of theta, that's your polar form, is equal to the ratio of y over x, which is used in rectangular form. So these are also ones that we will be using for conversions. Also, I think it's important to recognize that the point x comma y can now also be written as r cosine of theta and r sine of theta. And all I'm doing is replacing the x and y using our two equations up here. So this will be the information that we will need as we convert from one form to another. So to convert from polar form to rectangular form, this point represents r comma theta, and we want to change it to x comma y. Well, going back and looking at your equations, we have x equals r times cosine of theta. So we have the information to find the x. It would be 4 times cosine of 3 pi over 4. And the same thing for y. Y is equal to r times sine of theta. So y is equal to 4 times sine of 3 pi over 4. And now we can just evaluate. 4 times cosine of 3 pi over 4. That would be negative square root of 2 over 2. It is in quadrant 2. So x would be equal to negative 2 square roots of 2. And for y, you have 4 times sine of 3 pi over 4, which is positive square root of 2 over 2, which is equal to 2 square roots of 2. So the ordered pair in rectangular form of 4 comma 3 pi over 4 is negative 2 square roots of 2 comma 2 square roots of 2. So once again, same location, just a different way to write it. One's in polar form, which is the original, and then the answer is in rectangular form. Now we're going to look at going the other way. We're going to go from rectangular form to polar form. So to do this, it's important to be able to see the visual here. So we're going to plot the point negative 2, 2. So we can see what we're looking at here. So negative 2, 2, that would represent negative 2 and 2. And we can use that to find the r value. So we would use Pythagorean theorem, negative 2 squared plus 2 squared is equal to r squared. And then that'll be 4 plus 4. So 8 is equal to r squared, and r is equal to the square root of 8. So r is equal to 2 squared to 2. And I can put the plus or minus because remember that r, that distance could go the opposite as well, and we just need a different angle. So we can use positive or negative 2 when we write the polar form. Now we need to know what the angle is. What is the angle formed to get to that ray? Well, since we have the location in terms of our x and y value, we can use one of our trig functions, preferably tangent, because it uses x and y. Tangent of theta is equal to the opposite, 2 over negative 2, or negative 1. So where is tangent of theta equal to negative 1? But remember, you are in quadrant 2. So if that's the case, that would be a pi over 4. So therefore, tangent of theta would be 3 pi over 4. And so once again, the way we set up this polar coordinate, it's not a unique point. So we can find different points to indicate that same one. If we stick to kind of everything in terms of our positives with r, we'd have 2 square roots of 2, comma, and then what is the angle that gets us there, which would be 3 pi over 4. So that's one possibility. If you did want to use the negative 2 square roots of 2, remember it'd have to be opposite, so we'd have to go down into quadrant 4. We could label that as 7 pi over 4. Once again, on this one it says that theta needs to be between 0 and 2 pi. So either one of those would be fine because our answers are between 0 and 2 pi. There are plenty more, but if we're trying to stick with theta between 0 and 2 pi, it'd have to be one of those two values. Alright, let's take a look at the second one. Maybe pause the video at this point, and now that you've seen it once, go ahead and see if you can do it on your own. This point is located in quadrant 3, so x is negative 3 square roots of 3. And y is negative 3. So we'll do the same thing. We'll find the r value by using Pythagorean theorem. So negative 3 square roots of 3 squared plus negative 3 squared is equal to r squared. So if you square negative 3 squared to 3, remember you got to square both of them, so it'd be 9 times 3 would be 27. So it'd be 27 plus 9 equals r squared. Or 36 equals r squared, so r could equal positive or negative 6. Now we want to know what this angle is. So we'll do the same thing as we did last time. We'll use tangent of theta, and that would be negative 3 over negative 3 square roots of 3, which would be equivalent to 1 over the square root of 3, or square root of 3 over 3. So where is tangent of theta equal to the square root of 3 over 3, but in quadrant 3? So for this one, that'd be a pi over 6, and pi over 6 in quadrant 3 is 7 pi over 6. So we do want to find two sets of polar coordinates, so we will do a positive r value first. That would be 6, comma, and then that would be our 7 pi over 6. And then if we had a negative r, negative 6, once again that goes in the opposite direction, so it'd have to be in quadrant 1. So that would be pi over 6. And so once again, that's how you take a point in rectangular form and change it to polar form. And then the last thing we're going to look at is quadrantals. So I have rectangular x comma y on top, and then polar r comma theta on bottom. So we'll name them both ways. So for the first one, in the angle 0 or 2 pi, this distance right here is a. So in rectangular form, a comma 0 is your, remember that's your x, you moved a units to the right, but 0 units up and down. But in polar form, your r value is the a, That is correct. But this one, even though it's going to look the same the way we write this 0 represents the angle. Okay, so that is 0 radians. And then the A is the distance from the pole to that point. Alright, so make sure you know the difference. Even though those points are labeled the same, they represent different things for each of those. This 0 is your Y value, which you're not moving up or down. So different zeros on each of those. They represent different things. So the next point, your X value is 0. You're not moving left or right, but you're moving A units up. So this is still that distance of A. In polar form, you still have that distance of A, but now you want to look at that angle. So in polar form, this would be A, comma, and then what's that angle? Pi over 2. Okay, and remember, polar form, there could be different ways to write it. Rectangular, there's not. For the third one, you're moving A units to the left, so that's a distance of negative A, comma, 0. So once again, that distance still represents A, but it would be a negative A. Now in polar form, though, that distance, we're just interested in the distance itself. So the distance is still A, but the angle that is formed is pi. So A, comma, pi. And for the last quadrantal, you move 0 units left and right, but you move A units down, so that would be a negative A value in terms of your Y value there. And then in polar form, so remember, we're looking for this angle, but the distance is still the same. It's still that A value. So it's still A, comma, but this would be 3 pi over 2. And so there are the 4 quadrantals in rectangular form and in polar form. And that's it for day 2. Write down those important pieces that you will need to make sure you understand the lesson.